2003 Canadian Open Mathematics Challenge, Part A. Jeff, Gareth, and Ina all share the same birthday. Gareth is 1 year older than Jeff, and Ina is 2 years older than Jeff. This year, the sum of their ages is 118. How old is Gareth? Based entirely on the question stem, G for Gareth, is J plus 1, J for Jeff. I for Ina is G plus 2, and the sum, which would be G plus J plus I, is 118. So we just have to work with these equations now. I'll substitute, let's see here, G is J plus 1, so I'll substitute that there. So I becomes J plus 1 plus 2, so I is equal to J plus 3. And then now we have everything in terms of J. We can just plug it into there. So J, I just leave it the way it is. G is J plus 1, and then I is J plus 3. And that's 118. So this is 3J plus 4 is 118. So 3J is 114, and therefore J is 38. And what do they want? They want Gareth. So Gareth is J plus 1, so that means Gareth is 39. The point 4, -2 is reflected in the x-axis. The resulting point is then reflected in the line with the equation y equals x. What are the coordinates of the final point? Okay, well, they've already labeled that point 4, -2. It's reflected in the x-axis. So the x-axis acts like a mirror, I guess. So if you're reflecting in the x-axis, it would go basically up here, right, somewhere. So the x-coordinate would not change, but the y-coordinate would change, of course. We went down 2 units. If you reflect it, it would go up 2 units. So it would be 4, 2. So 4, 2 is right here. 4, 2. And then it says that it's now reflected in the equation, in the line with the equation y equals x. When that happens, the x and y coordinates just reverse. So if you had a coordinate, it would just go from xy to yx like that. If you reflect it in the line y equals x. So this now becomes 2, 4. So 2, 4 is where? Here? Right here. 2, 4. And that's it. That's all they wanted. So 2, 4 is the answer. A circle of radius 1 is centered at the origin. 2 particles start moving at the same time from the point 1, 0 and move around the circle in opposite directions. One of the particles moves counterclockwise with constant speed v, and the other moves clockwise with constant speed 3v. After leaving 1, 0, the 2 particles meet first at point P and continue until they meet next at point Q. Determine the coordinates of Q. Okay, well, throughout this question, we are going to use some basic formulas, right? That circumference is equal to pi times diameter. And in this case, the circle is radius 1, right? So that means that the diameter is 2. So circumference is equal to pi times 2. And then the other formula is that speed is equal to distance over time. And I think that's it in terms of equations. So let's start talking about the diagram. First, you have one particle that's moving counterclockwise, right, with the speed of v. So it's going in this direction here, and that's the one that moves at the speed of v. The other one is clockwise with the speed of 3v. So it's moving in this direction, but that speed is 3v. And because this one is faster, obviously it's going to travel faster. It's going to go it's going to travel a longer distance. Now, just based on sort of common sense, this will travel 3 times the distance. So if this particle reaches to this point, which is exactly a quarter, this will travel 3/4. So we'll get to basically this point right here when they meet for the first time. Now, let's say, you are not convinced of that. You think, well, I don't know. I don't know if that's actually true. Okay, no problem. If you're not convinced, let's do it the mathematical way, which is that way. So for V, this guy, we'll just call it T1, the time. And the time, if you modify that formula, is D over S. Now D1 is what I'm interested in, but S we know they've given us as V. And then the equation for this guy will be very similar. We'll call that T2. Again, it's going to be D over S, but we'll call it D2. And then the speed is 3V. Now when they meet, both these times are the same when they meet for the first time. So that means that D1 over V is the same as D2 over 3V. Correct? And then the V's cancel, so D1 times 3 is D2. So there I proved it mathematically that D2, the distance that this guy travels, is 3 times the distance that this guy travels. So just looking at this diagram, I hope you're convinced now that that's the first meeting point. And you can easily tell from the graph that the coordinates of that is 0, 1. So let's put that in there. 0, 1. All right. Well, unfortunately, that's not the end of the story, because they want you to find when they meet again. So they meet first at point P. So I guess this is your point P. And then they continue until they meet again at point Q. Okay, so we got to find point Q. Okay, not a problem. Again, you can do it mathematically like I did here, or you can do it based on just common sense. I encourage you to do it mathematically because these questions are graded sort of like they look at the full solution. They don't just give you an A, B, C answer choice, right? This is a different kind of contest. So I encourage you to do it that way and explain. But the same philosophy is now in place that as this particle travels and this particle travels, this guy will always travel 3 times the distance. So if this guy is here and it's going to go, let's say, to here, this particle will have traveled 3 times the distance. So it will have gone all the way around there to meet again. So this will be my Q right here. Without a doubt, I'm pretty confident about that. So that will be my Q. And the coordinates, obviously, are -1, 0. So there you go. And like I said, you can show in the same way that the distance from P to Q will be behaving in the same way that this particle will travel 3 times the distance as that particle. So you can easily do that. 2 different numbers are chosen at random from the set 0, 1, 2, 3, 4. What is the probability that their sum is greater than their product? Okay, so you're choosing 2 different numbers. So for the first number, we have 5 choices. The numbers are different, so you can't choose the same number. So now for the second number, we have only 4 choices remaining. And then the total number you multiply, so there's 20 possible outcomes, I guess. Since 20 is a pretty small number, we can sort of do this manually. So I'll do it really quickly. These are my possible combinations of 2 numbers, 0, 1, 0, 2, 0, 3, like that, right? And then similarly, 0, 1, 1, 0, sorry, 1, 3, 1, 4. Remember, 2 different, so I can't have 1, 1. I can't choose the same number twice. And in a very similar way, 2, 0, 2, 1, 2, 3, 2, 4. A few more, 3, 0, 3, 1, 3, 2, 3, 4. And then finally 4, 0, 4, 1, 4, 2, 4, 3. So these are my 20 combinations. Now we have to look at their specific condition that they want the sum greater than the product. So for each of these, we'll put an S and a P. Let's separate this so we don't get confused. For each of these, we'll get an S and a P. S&P 500. Some of you guys know what that is. It's a stock market index that tracks stocks in the United States. Okay, anyhow, sum is greater than the product. So we got to write out all the sums and the products, and then we'll compare it. Okay, so this is pretty easy. Sum of the products. So here we go. 1, 0, 2, 0, 3, 0, 4, 0. Okay, 1, 0, 3, 2, 4, 3, 5, 4. 2, 0, 3, 2, 5, 6, 6, 8. 3, 0, 4, 3, 5, 6, 7, 12, 4, 0, 5, 4, 6, 8, and 7, 12. Okay, so now which one of these has that condition that the sum is greater than the product? I'll just circle them. Sum is greater than the product. This guy, this guy, this guy, this guy, all of those. Sum is greater than the product. Here, 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 and here, all of those. This one, this one. Okay, not these two, because as you can see, the sum is not greater than the product there. Over here, just this one and this one. And in the last one, these two. Okay, hopefully I circled the right ones. Now let's count them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 of the 20 is the probability. And in lowest terms, that's 7 over 10. And that is the answer. In the diagram, square ABCD has side length of 6. Circular arcs of radius 6 are drawn with centers B and D. What is the area of the shaded region? Very common type of question. Key to this question is to draw one line from A to C, and then things start to become quite clear. And then that line obviously cut that shaded region in half, right? So one of those regions I'll call A. So this is A and this is A. So in the end, I guess I'm really trying to find 2A. Now what is A? A, if you look at this carefully, is basically a quarter circle, right? So pi r squared over 4 minus this triangle. And that triangle, as always, is 1/2 base times height. The base is 6 and the height is 6, since it's a square of length 6. And that's it. So pi, what's radius? What is the radius of this circle, or quarter circle? Well, the radius is 6 also. So that would be 6 squared over 4, and this looks like 18. So this is 36 divided by 4, 9. 9 pi minus 18. Now, be careful here. We have to find 2a. So don't just leave it at that. So therefore, 2a would be 18 pi minus 36. And that is the area of the shaded region. The symbol a bracket means the greatest integer less than or equal to a. For example, 5.7 bracket is 5. Bracket is 4. Negative 4.2 bracket is negative 5. Determine all values of x for which 3 over x bracket plus 4 over x bracket is equal to 5. So I hope you understand the definition, and here we go. Now, immediately when I look at this, I can make a few conclusions, right? The first is that x is not equal to 0, because you cannot have 0 in the denominator. It would be undefined. Okay. Well, is x greater than 0 or is x less than 0? Let's see. If x was less than 0, then that would mean that 3 over x is less than 0. It would be a negative number. Correct? And then if I took that bracket, the bracket doesn't change the sign, right? If you look at this example right here, so this will also be less than 0. This is a good example of that. So even if it's negative something, it's just going to drop it down to the greatest integer. So the greatest integer less than that less than that, right, is negative 5 in that case. In a very similar way, 4 over x would also be less than 0. And then when you did the bracket, it would also be less than 0. So this and this would be both less than 0. So when you added them, obviously there's no way they could be 5. Two negative numbers added together would never be able to equal a positive number. So my only conclusion is that x is greater than 0. Okay, so that is sort of the first thing we needed to establish. Since we concluded that x is greater than 0, we can conclude that 3 over x is less than 4 over x. Correct? If this is a positive number, the larger numerator would be greater. That's pretty obvious. So therefore, when we do the bracket part, it's also going to be similar. But they could be equal because you could have, for example, 5.2 bracket and you can have 5.3 bracket. 5.3 is definitely greater than 5.2, but when you do the brackets, they both become 5 and therefore they become equal. So that's why I put this equal sign in there. Okay, so just establishing some basic things. All right, so let's move forward here. In this equation, we know for a fact that both of these guys are integers, this and that. When you do the symbol part of it, it has to become an integer. So that means that we have not that many choices for what they can be. Since they're both integers, we'll make a little table here. What could they be if they both add up to 5? And we know they're both positive integers. That's another. Or we know they're positive integers since we've already discussed that. Okay, so what are my choices here? This could be 0. This would therefore have to be 5. This could be 1. This would therefore have to be 4. This could be 2. Therefore, that would have to be 3. Now, I can't keep going. I can't do a 3, 2 because remember, this has to be greater than that. So the 3, 2 would not match that requirement, that inequality. Now, I know you might get a little confused with this one. You say, well, how's that possible? You just said that x cannot be 0. Yes, 3 over x can never be 0. But if you did the bracket, then that could be 0, correct? Because, for example, the number 3 over x, this number could be, say, 0.4 or 0.5, whatever. And then when you did the bracket, it would drop it down to the greatest integer less than, which would be 0. So I just wanted to make sure you don't get confused there. Okay, so let's work with the first one here. If that's the scenario. If that is the scenario, then that means from the first one that we have 3 over x is that the bracket is equal to 0. So that essentially means that x is greater than 3. If x is greater than 3, this would become less than 1, and then therefore when you did the bracket, it would drop it down to 0. Okay, now what about this guy here, the 5 part? If 4 over x is equal to 5, then that means that 4 over x is going to be between 6 and 5. And that, because when you drop it down just by the definition, it's got to be 5 point something, 5.1, 5.2, and that's why I got this inequality. And therefore, if you isolate for x would have to be either less than or equal to 4 over 5 or greater than 2 over 3. So we have to see, are there any common solutions to those two guys? And the answer is no. No solutions. If x is greater than 3, then it doesn't fall into that range. So there are no solutions there. Okay, not a problem. Just keep going here. Keep going in the same way. All right, same kind of story. If 3 over x, the bracket is equal to 1, then let's see what we get. Same kind of philosophy here. 3 over x would therefore be between 1 and 2. And therefore, if we isolate for x, it'll be between 3 over 2, sorry, and equal to 3. Yeah. Okay. Next one, if this 4 over x bracket is equal to 4, then that means that 4 over x is between 5 and 4. Isolating for x, we would get x between 1 and 4 over 5. Now, these two, do they have a solution, anything in common? And it seems like the answer is no again. No solutions. Okay, so our last hope is this guy. If 3 over x is equal to 2, what do we get? We get that 3 over x is between 2 and 3. And isolating for x, we get that x is between 3 over 2 and 1. If 4 over x bracket is 3, then that means that 4 over x is less than 4, but greater than or equal to 3. Isolating for x, we get x is between 4 over 3 and 1. Do these have a common solution? And the good news is, yes, they do. That common solution is x is between 1 and 4 over 3, right? 4 over 3 is smaller. Yeah. And there you go. That is the only range in which this is true, right here. X is between greater than 1, less than or equal to 4 over 3. Each of the points 4, 1, 7, minus 8, 10, 1, PQR is the midpoint of a radius of circle C. Determine the length of the radius of circle C. Okay. Well, the first thing, I'll just draw a circle and kind of talk about this before we kind of get into it, because it might seem a bit obscure, but it's not that bad. Let's say you have the center, it's going to be approximately there, right? And then you've got these 3 points. Let's say the 3 points are here, let's say here, and let's say here. If you join the center to the edges, those are obviously going to be radii. Each of those is a radius. And those points are the center of the radius. So that's basically what the question is saying. So, well, okay, how do we approach this question? Well, we know for a fact that these 3 distances, this one, and this one, will be the same. And if they are the same, then we can use the distance formula to just create those equations and set them equal to each other. So that's basically all it is. And it doesn't have to be a work of art, you know, your diagram. I'll just do a very basic one, actually. So the first point is 4, 1, so approximately here, say 4, 1. This is just to illustrate. 10, 1, let's say around here, 10, 1. And then, what is it? 7 minus 8. So way down here somewhere. 7 minus 8. So what they're saying is exactly what I explained here. So I'm just going to pretend that I know where the center is. I'm just going to guess. Now, let's say the center of that circle is here. I have no idea. And then when I join these guys like that, those 3 distances should be exactly the same, exactly the way I explained in that circle. Okay, so the center, I'll call it AB. I don't know the coordinates. So that basically means this was P, this was R, this was Q. It means that P, I got to label it, right? So let's call it C for center. PC is equal to RC is equal to QC. And then we can use the distance formula. We're going to get 3 equations, set them equal to each other, and then solve for A and B. Because what do they want? They want the length of the radius. Okay, well, then we can figure that out later on. First, we need the coordinates. Once we get the coordinates of AB, we can find the distance And then since this is representing the midpoint, we just double that to get the radius. Okay, so here we go with the distance formula. D would be equal to PC. What is that going to be? We're going to use 4 and 1, right? So A minus 4 squared plus B minus 1 squared, all under the square root. And the next one, RC, same distance. So that's going to be A minus 10, or 10 minus A. Doesn't really matter how you do it. A minus 10 squared plus B minus 1 squared, all under the square root sign. The next one, QC, A minus 7. Yeah, A minus 7 squared. And then B plus 8, because it's minus minus. And there you go. Okay, so all these three are equal to D. So set them equal to each other. These two actually look very similar, so I'm going to do that. A minus 4 squared plus B minus 1 squared is equal, all under the square root sign, is equal to A minus 10 squared plus B minus 1 squared, all under the square root sign. If you square both sides, you get rid of the radicals, and you just get left with what's inside, like this, right? There we go. Now what you do is you get rid of these guys. They're the same on both sides, so it's great. It makes our calculations very easy. So all you're left with is just the A's. And then we can easily solve for this. We can just expand it at this point. Let's see here. A squared minus 8A plus 16. And on this side, A squared minus 20A plus 100. The A squareds disappear, which is great. Put everything on one side, like terms, that kind of thing. And we get 12A, and this side we get 84. Solving for A, we get A equals 7. Perfect. And then substitute A equals 7 into any one of these three equations to solve for B. And I guess I can do it. Doesn't really matter. I'll just put it in here. So let's move this up a bit. So A is 7, so if I put it in that equation, D would be equal to, or actually, I don't know D, so I can't use that. I have to set them equal to each other and then solve. Okay, so I guess I can just put it any one of these. So I'll set this guy equal to this guy, and then I'll substitute in A equals 7. So A minus 7 squared plus B plus 8 squared is equal to A minus 4 squared plus B plus minus 1 squared. Now I'll substitute my A equals 7. When I do, this becomes 7 minus 7 squared. B is what we're trying to solve, so we don't know that. I'll square both sides also to get rid of the radical sign. This is going to be 7 minus 4 squared, and this is B minus 1 squared. Okay, this looks like it's pretty easy to solve. 7 minus 7, well, that vanishes. B plus 8, B squared plus 16B plus 64. 7 minus 4 squared is 3. 3 squared is 9. So 9 plus B squared minus 2B plus 1. B squareds disappear again. Put everything on one side, and you get 18B is equal to minus 54. And therefore, B is equal to minus 3. Okay, great. So we got A, we got B. Now what we can do is you can calculate one of these D's. And then our radius will be 2D, right? Because these were the midpoints, if you recall, in the question, just like the diagram. D is sort of this distance right here. And since this is the midpoint, the full radii would be 2D, right? The full radii would be 2D. Okay, that's pretty straightforward. So D, use any one of these equations. I guess I can use this one. Anyone is fine. A is 7, so 7 minus 7 squared. Plus B is minus 3, so minus 3 plus 8 squared. And that looks like that's 0, and that's 5. 5 squared, 25. Take the square root. D is 5. And therefore, the radius is 2D, and that's 10. So there we go. 10 is the radius of that circle. Determine the number of triples KLM of positive integers such that k plus L plus M is 97, 4k over 5 plus 5L over 6 plus 6M over 7 is 82. Let's just keep, everything simple here. Let's just add this as a fraction. So the denominator would be 5 times 6 times 7. Up here we'd have 5 times 6 times 4k. And then you'd have 5 times 7 times 5L. I'm going to use a capital L because otherwise it'll look like a 1. And then here we'll have 5 times 6 times 6m. And that is all equal to 82. Okay. Somewhere we're going to use that equation to help us. Okay, let's move through with this math here. So 5 times, this should have been 5 times 7. Sorry about that. 6 times 7, actually. That's okay, as long as I catch it early. So this becomes 42 times 4k. This is 35 times 5L. And this is 30 times 6m. It's just basically adding fractions. Then I'll put everything on one side. I'll cross multiply that guy. So that is going to be 17220. So now we have 168k plus 175L plus 180m is 17220. Now, can we reduce this? I don't know. I'm not sure if I can reduce it. But one thing is for sure, that the 168k will help because I'll put everything in 168, 168L plus 168m. And then what's left over is 7L and 12m. And that's 17220. The reason I did that is because if I factor out the 168, I have k plus L plus m. And then I can finally use that equation. And we have 7L plus 12m is our 17220. This is 97. So we got 168 times 97. And then the good news is it reduces it to 2 variables. So we can then kind of make a table and solve. 7L plus 12m is 17220 minus this guy, which is 16296, and therefore 7L plus 12m is equal to 924. Okay, that's great. So now we have to sort of kind of use our table format and make a little list of possible integer solutions because they're positive integers. Okay, so we basically need to find integer solutions to that equation, and they're positive integers. All right, so L and M, and then let's see here, I put K. K I will find later. Let's just concentrate on L and M. They're positive integers, so the smallest it can be is 1. So let's start off with 1. And I'll let you guys do the math. If you do the math, you find that this is 76.4. It's not an integer. So you got to keep going, right? And when you do, you find the first integer solution is 12. When L is 12, M is 70. And that's the first integer solution. And when you substitute L equals 12 and M equals 70 into that equation, you solve for k pretty easily, and you get a value of k as 15. So that's basically what you're doing, is you're just using this equation and that equation, just going through them integer by integer. And you can do this pretty quickly because you'll find that there's a pattern. So if you go up to 24 is when you get the next one, you'll find that m is 63. So basically, as you go down by 7, so instead of keeping at it, you just go down by 7 again, and you get to 56. This goes to 36. It's just going up by 12s. And then solve for k for each of these, and you get 10 and 5. And these are the only ones, because after this, you don't get any positive values of k, positive integer values of k. So these are the only three triples that satisfy these equations, matching the criteria that k, l, and m are all positive integers.